Okay, so we're gonna classify numbers, but and order numbers in this video. But first, I want to tell you something. So in this idea, I'm gonna give you an example. Let's say we had a hotel with each room going up. Each room is 1, 2, 3, 4, listed always going up. Now that would be our whole numbers right here. Okay. The beautiful thing is actually integers could fit in it. If every integer we put 1 and -1, 2 and -2. If we just plugged in each number in as we went up, we would have enough rooms for every integer. So the whole numbers and the integers in this hotel, this analogy that this hotel is infinitely large, that the integers would fit in it, okay? Now you might be like, no, that doesn't make sense. Okay, I can show you, explain this another time. But the problem is, once you get to rational numbers, they are infinitely larger than this integers, meaning that every room here, this is 1, this is 2, that between these two rooms is going to be an infinite number of rooms. And between these two rooms is going to be an infinite number. And in fact, that's the way it goes all the way up. So that there's not even one single room that could fit in here to break this amount of rooms. That's rational numbers. There's so many fractions between 1 and 2, or 0 and 1, that you could fill all the rooms of the whole numbers with just one of those sections, okay? Now, if I tell you that that's big, that rational numbers is big, then the set of irrationals is even bigger. This is bigger than this whole thing. There's so many numbers that are not able to be written as a fraction that this category is infinitely bigger than this category. So IR is going to be infinitely bigger than fraction. Okay? Now, you can attempt to do it, but it just rational. Let's call this rat. Okay? Now, the amazing thing is, these two categories are what makes up the real numbers. And if someone's over there, what about imaginary? Okay, you see how big this is. Real numbers is really big. Imaginary is infinitely bigger than real numbers. It is so much bigger that we describe it in 2 dimensions, whereas real numbers is a number line. That is, that for every point you have on the real numbers, you may have more than one point that fits in that point on the imaginary. Okay? So, real numbers is our number line, and we say that this is well ordered, meaning something bigger is always going to be bigger, something less is always going to be less. If they are equal, if they're in the same spot, they are equal, and meaning the same number. Okay? Classifying each number as real, rational, or irrational. So if something is everything that you're going to cover is going to be real. Imaginary would be the square root of a negative number. Okay? You're not probably going to see that in this class unless I decide to, have a class period about that. If you cannot take the square root of the number and it's a decimal, it's going to be irrational. Okay? If the decimal doesn't end. Okay? If it's irrational, it is a not irrational number, and it can't be an integer, and it can't be a whole number. Okay? If it is a rational number, then you can check, is it integer or a whole number? Okay? Whole number means positive, integer means negatives and positives. Okay? Okay, and then you order them from least to greatest, okay? Go from most negative to largest positive, okay? Okay, and that will be our lesson for today. So one of the things that I love about math with this whole concept of infinitely bigger and infinitely smaller is this concept actually kind of teaches us about God. And a characteristic that I actually find so fascinating is how can God, whose character is infinite by nature, so God is infinite, right? But he can't stand, infinite. Okay? If God is infinite and his holiness is unapproachable, meaning there's no comparison, meaning again, his holiness is infinite, a quality that's just beyond comprehension. It's not a number. There's no numerical value. It can't be captured in quantity or quality, except that he is holy. How can he forgive sin, which again is the opposite of his character, the very thing that he detests and hates? And we don't have quality again to explain how much we hate it, how much he hates it. Like we can't fathom that one. But that tells me just how important the sacrifice is. Because of Christ's death, does it somehow fit this or fill this infinite expectation? And then we don't have hope. But if Christ's death does satisfy this quality, this need, not need, this aspect, this characteristic of God, if his death does satisfy it, we have hope. Sin is then covered. So this quality is fascinating to me, and it relates to more than just that. There's so many fields of math this quality of infinity relates to. But in Algebra 1, how far can we go with that? But yeah, so just consider, as you do these number lines, realize that between that 0 and that 1, infinite amount of numbers, can't possibly fathom that as you count, you are going through, what I would say is in the simple, we actually are walking in profound thoughts. We miss it if we don't look carefully. So maybe take this opportunity to look carefully at some ideas you might have taken for granted. And obviously, have a wonderful day. I'll see you guys shortly.